Video to explain how ESCs work, electronic speed controls. They take the power from a battery and power the motors on a quadcopter. As you can see, this is what they look like under their covers. Battery connects with two wires, it's DC, and the output is three-phase AC. Using these 6 MOSFETs, there can be more, but this one has 6. These switch the voltage between these 3 wires at different steps to create a kind of artificial wave, and that's driven by this main chip here, an IC. Quadcopter motor. You can see there are more than 3 magnets, electromagnets. These switch on and off. On the outside are permanent magnets. These electromagnets alternate between the 3 different phases, the 3 different wires. So this is A, B and C, then it's A again, then B again, then C again. It keeps going all the way around, so they'll be in multiples of 3. And there'll be more permanent magnets, the magnets on the outside, than there are electromagnets on the inside. So they're slightly offset, you can see. The ESC takes signal from the flight computer through this wire, which tells the ESC how much power to give the motor. That determines the speed of the motor, which determines the rate of which these switch through these transistors. And the way it knows when to fire these, depending on how quickly the motor's rotating, is using back EMF, which is electromagnetic voltage that comes back from the motor through these wires. So it's actually reading voltage as well as sending voltage. Back EMF is produced by these magnets. As they pass the electromagnets, they send a voltage back down through the ESC. As this rotates quicker, the voltages switch quicker between the A, B and C, and that allows the ESC to tell when it should fire or when it should switch the next transistor on. So there's some estimation software that estimates when is the correct time based on an average of when these are sending back voltages, back EMF.